Hi, today we are going to see some more problems in surface areas and volumes. So let's solve some more problems. A 20-meter deep well of diameter 7 meter is dug. The earth taken out of it has been spread evenly all around it in the shape of a platform 22 meter by 14 meter. Find the height of the platform. So a well is dug and the sand taken out from it is made into a platform. Now what we are going to do is find the height of this cuboid. Okay, to find the height what we have to do is equate the volume. Since the earth taken out from this well is made into a platform, obviously both the volume must be equal. So we are going to equate the volume of both these. Okay, so what we are going to do is volume of cylinder is equal to, we are going to equate it to volume of cuboid. So now we know that the volume of cylinder formula is pi r square h, which is equal to volume of cuboid, which is L into B into h. Here we don't know what is h, that is what we are going to find out here. Okay, let's substitute. Instead of pi I can substitute 22 by 7 into r square is nothing but 7 by 2 into 7 by 2 into height h is 20 equal to length is given as 22, breadth is given as 14 and height is what we have to find. Okay, I can cancel this 7 and this 7, this 2 and this 11, so and this 2 and this 10. Okay, so I can also cancel this 11 and this 22, so it is 2. So I am left out with 70 equal to 28 h. So 70 divided by 28 is what the height. Therefore, when I divide, I will get height as 2.5 meters. Let's do some more problem. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter, 10 centimeter, 3.5 centimeter. So from this question we can find that so the volume of both, we are going to divide the volume of both of these so that we can get the number of silver coins that can be made. So we are going to divide the volume of cuboid divided by volume of the coin, which is a cylinder, so that we will get the number of coins. So number of coins is equal to volume of cuboid divided by volume of cylinder, that is the coin. So we know that the volume of cuboid is L into B into H and the volume of cylinder is pi r square H. So we are going to substitute it here. So we know the length is 5.5, but here we have to note that these dimensions are given in centimeter and the thickness is given in millimeter. So what we have to do is convert this centimeter to millimeter. So when we convert this centimeter to millimeter, we have to multiply it by 10. So when I multiply 5.5 by 10, I will get 55 millimeter into, when I multiply 10 into 10, I will get 100 millimeter into 3.5 into 10 is 35 millimeter divided by 22 by 7 for pi into, so for the diameter it is given in centimeters. So to convert it to millimeter I will multiply it by 10. So 1.75 into 10 is nothing but 17.5. So for it is diameter, so for radius I have to divide it by 2. So 17.5 by 2 is the radius into 17.5 by 2 into height is 2. Okay, so here we can cancel this 2 and this 2, then this 2 and this 22, 11 and 7, this one I can cancel, it is 2.5. So when I multiply I will get 17,500 divided by 43.75. So which is nothing but 400 coins. So we can make 400 coins out of this cuboid. Now we are going to deal with problems based on frustum. Okay, frustum is nothing but it's similar to the shape of a cap. Okay, a fez, the cap used by the Turks, is shaped like the frustum of a cone. If its radius on the open side is 10 centimeter and the upper is 4 centimeter, slant height is 15 centimeter, find the area of material used for making it. So we are given with the radius R1 as 10, R2 as 4 and the slant height L as 15. Now what they are asking is area. The formula to find area is equal to pi into R1 plus R2 into L. So instead of pi we can substitute 22 by 7 and R1 is 10 plus R2 is 4 into 15. Here we have to note that we are going to find the area of material used for making it. This area is nothing but only the surrounding material need to make this cap. We know that the upper lid of the cap should be made to close the upper lid. So it is nothing but a circle. So we have to add area of circle nothing but pi r square. This r is nothing but the r2 upper radius. So here I will be adding 22 by 7 into r square is 4 into 4. Okay, so while solving this we will be getting 660 plus 352 by 7. So when I take LCM I will get 4620 plus 352 divided by 7. So when I divide and make convert it to mixed fraction I will be getting 710 by 7 centimeter square is the area of material needed to make this cap. A container opened from the top and made up of a metal sheet is in the form of a frustum of a cone of height 16 centimeter and radius of its lower and upper are 8 centimeter and 20 centimeter. Now we have to find the cost of milk that is contained in the container at the rate of 20 rupees per liter. Also we have to find the cost of metal sheet needed to make that container at the rate of rupees 8 per 100 centimeter square. So first to find the cost of the milk in the container, we have to find the volume of the frustum. So volume of the frustum formula is pi 1 by 3 pi into h into r1 square plus r2 square plus r1 into r2. So here I can substitute 1 by 3 into pi is 22 by 7 into height is 16. So R1 is nothing but 8 square which is 64 plus R2 square is 20 square is 400 plus 20 into 8 is 160. So I will be getting 1 by 3 into 22 by 7 into 16 into 624. This 3 and this gets cancelled and we will get 208. So and the answer is after multiplying and dividing by 7 I will get 10,459.42. It is in centimeter cube. Now I have to convert it to liters. So I should divide this by 1000 to convert it to liters. So I will be left out with answer 10.459. It is given that 20 rupees per liter. So the total cost is equal to 10.459 into 20. So which is nothing but rupees 209.18, which we can approximately round off to 209 rupees. Now we have to find the cost of the metal sheet to make this container. So here what we are going to do is find the area. So area is equal to pi into R1 plus R2 into L plus pi R square, since the bottom of the container should be closed. Okay, so when we substitute here, instead of pi we can substitute 3.14 into R1 is 8 plus R2 is 20 into L we have to find plus 3.14 into R square. For R square it is the lower radius which is 8 square. So 3.14 into 28 into L plus 3.14 into 64. For L, we have the formula L is equal to root of h square plus R1 minus R2 the whole square. So we know that the h square, h is nothing but 16. So h square is 16 square plus 20 minus 8 the whole square. So 16 square is 256 plus. So it is root of 400 which is equal to 20. So instead of L I can substitute 20. So the area is equal to 3.14 into 28 into, instead of L it is 20 plus 3.14 into 64. So when we multiply we will be getting 1758.4 plus 200.96. So when we add we will be getting the answer 1959.36. We know that for rupees 8 for 100 centimeter square. So for 1 centimeter square it is 8 by 100 which is equal to 0.08. So I have to multiply this with 0.08 to get the cost. So the cost for making the metal sheet is around rupees 156.75 is the total cost.